I can't hear, sir.
Right, children. Today we are going to learn comparison of fractions. There are basically two ways with which you can compare the fractions. Right? Okay. Method number one. First method. If the numerator is the same, larger the denominator, smaller will be the value of the fraction. If the numerator is the same, larger the denominator, smaller will be the value of the fraction. Now, what are we to learn here? What are we to understand? Let's see, children. Very simple, very easy. I have a slab of chocolate. I cut it into 4 parts. Yeah. Same slab of chocolate. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9, 10. 10 parts. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. What I would do is, I will color 3. What is this now? 3 upon 4. What I would do is, I will color again 3.
10
1, 2,
upon
3.
3.
Are they?
10 upon 3.
No, we call it as 3 upon 10. What is it? 3 upon 10. Now here, 3 upon what to say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now what is the smallest part? Here 3 parts I have colored. Yeah. Here also 3. Here also 3. If the numerator is the same, larger the denominator, smaller will be the value of the fraction. Therefore, if I am write this in ascending order, what order, children? Ascending order. What do you mean by saying ascending order?
Smaller to bigger.
Smallest to the biggest. What is the smallest fraction that we have? 3 over 17. Next, what we have? 3 over 10. Next, what do we have? 3 over 4. Now we understand from the basic comparison of fractions, what is it? If the numerator is the same, larger the denominator, smaller will be the value of the fraction. That is done. We have another explanation for this, right? Let's see what this explanation is. If the denominator is the same, larger the numerator, larger will be the value of the fraction. What is it, children? If the denominator is the same, larger the numerator, larger will be the value of the fraction. Let's see. 1, 2, 3. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm right drawing and counting so that it will be easy for you to understand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now what am I going to do? I'm going to color this. Right? Now 1, 2, 3. 3 upon 10. Yes? Right. 1, 2, 3, 4, 5, 6, 7 upon 10. Right? Let's look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 over 10. Now, how do you write this in ascending order, Pute? How do you write this in ascending order? 3 over 10, 7 over 10, and 9 over 10. Yes or no? Are we clear? Somebody asks you to write in the other way. Descending order. What is descending order, Pute? Largest to the smallest. What is largest to the smallest? 9 over 10, 7 over 10, and 3 over 10. Did you understand this? Yes or no? All of you understood, children? Yes? Yeah, good. Take this down, you guys, fast. We have to move forward, ahead, and do it fast. Really, very fast. Okay.
Joa meio kiwi. Mute the. So I'm done.
Sir, finish. Sir, finish. Sir, I have done my.
Alright, children, now we know if the uh, if the fractions are having different denominators, different numerators, what to do? Comparison of fractions. If the numerator is the same, larger the denominator, smaller will be the value of the fraction. If the denominator is the same, larger the numerator, larger will be the value of the fraction. So ascending, descending orders, I have taught you, you know what needs to be done. Yeah, very clear. Perfect. Good. Now, children, can you remember that we did something called equivalent fractions in grade 6? Can you remember? Yes or no? Yeah?
Yes,
Right.
sir.
Yes, Pute. Now, what are we going to learn? Now, will we be able to compare two fractions? Two fractions in the sense like this. 2 upon 3 and 1 upon 2. Which one do you think is the greater one? Here we can do this in different multiple ways. What I can do is make the numerators the same. I can make the numerators the same. Yes. How can I do that? I can have it as 2 upon 3. Yeah. 1 over 2. I can multiply top and bottom both. Yes. Now 2 upon 3 and 2 upon 4. Which is large now? Look at this. 2 upon 3 is 2 upon 3. Make the numerators the same. 1 over 2, I make the numerator by multiplying top and bottom by 2. I converted the numerator to 2. Therefore, when the numerators are the same, larger the denominator, smaller will be the value of the fraction. Therefore, this is the bigger fraction. Yes or no? 2 upon 3 is larger than 2 upon 4. That is what I have to explain. But usually we do not make the numerators the same. What do? We make the denominators the same. What do we use? What is the methodology that we use to make the denominator the same? Calculate the LCM. We calculate the what, children? LCM. Right? We calculate the LCM. What do we do now? We have 3 and 2. There are certain things that we should do. Yes or no? What is it? Divide using prime numbers only. Next one, we cannot have decimals or fractions as the answers. Part 3, we should divide till we get 1 as our final answer. We should divide till we get 1 as our final answer. So what are we going to do? I will divide this by 2. 3 and 1. Of course, yes, I can divide 3 by 2, but I wouldn't do that. The reason is, if I were to divide 3 by 2, I'll get a decimal. Now I'll divide this by 3. So what is the LCM? We have done this before. LCM is 6. Right. So how do we calculate with the LCM is, say, 2 upon 3. I need to convert this denominator to 6, so I multiply top and bottom both by 6. Here, in order for it to become 6, I multiply top and bottom by 3. What do I have now? 4 upon x, 3 upon 6. Again, 2 upon 3 is greater than 1 over 2. Did I make myself clear, children? Yes or no? Yeah?
Yes.
Okay, good. Take this down, guys, please. Fast. And Hiruki, thank you for letting me know, darling.
Saya mau berangkat.
Children, have you done? Did you finish taking this down? Have you finished taking down? Yes or no?
No, sir.
All right, okay.
Yes, sir.
Right, take it down fast, please.
Finish, sir.
Okay, darling. Right? Yes?
No.
I don't know. We are going to finish this fractions part 1 and move on to fractions part 2, children.
Sir, I done my work.
Is there anyone who's taking down the note yet? Please let me know. Yeah, I'm going to report now, children. It's too much time. Right. Now let's look at this particular question again. Very simple and very easy question. For those of you who couldn't get the answer, in fact, children, we can not only find or write the fractions in ascending order. We can write actually the fractions ascending order for not only for two fractions, we can actually use three or more fractions as well. Now let's look at this. Very simple and very easy. 3 upon 5, 2 upon 6, 7 upon 10. What do we do here now? We should be able to find the LCM for these three numbers. Find the LCM of the denominators. Yes. 5, 6, 10. Divide by 2, 5, 3, 5. Divide by 3, 5, 1, 5, 1, 1, 1. Therefore, the LCM is 2 into 3 into 5, 30. What is the LCM, children? 2 into 3 into 5, 30. What should be our objective now? How do I convert 5 to 30? I multiply by 6. I have to multiply the numerator also by 6. 2 over 6. How to convert it into 30, children? Multiply it by 5. Multiply this by 5, which is 10. 7 over 10. How do you multiply it by into 30? Times 3. Now, which is the larger fraction here? Smallest fraction? 10 over 30. Next, 18 over 30. And next, 21 over 30. But we do not write the answers as such. We write the original fraction. 2 upon 6 is the smallest. Next, we have 3 upon 5. And last but not least, we have 7 upon 10. This is how we compare and write them. If you want, you may put this to show that how the values increased from one fraction to the other. Did you all understand that, children? Yes or no?
Yes, sir.
Right, take this down, children.
So I'm done, sir. Done, sir.
Is anyone who is still taking down? Hmm. Right, children, is that's enough. That's enough time to take. Right? Yeah. Now mixed. Now compare mixed numbers with equal whole. Yeah, whatever. How do we compare and contrast mixed fractions? Let's see. Let's look at this. 3 and 5 upon 7, 11 and 5 upon 7. Which is larger? 3 and 5 upon 7 or 11 and 5 upon 7? Tell me.
11 and
and
5.7.
5.7.
Pretty easy, right? So this is larger. Right. Now you are tell me which is larger? 2 and 2 upon 3 or 2 and 4 upon 6? Which is larger?
2 and 4.6.
No.
And
Mm,
Since the whole number is large, we can easily understand which is the larger fraction. Yeah? Okay. Since the whole number is large, we can easily understand which is the larger fraction. Right. Further moving forward, we should convert mixed fractions to improper fractions. Do you know how to convert mixed fractions into improper fractions? Yes or no?
yes, sir.
yes, sir.
Yes,
Yes.
sir.
Yes, we know them, don't we? Yeah. We know how to convert mixed fractions into improper fractions. What do we have? 2 times 3 plus 2 over 3. What is it? 2 times 3? 6. 6 and 2? 8 over 3. Here 2 times 6 plus 4 over 3. 12 plus 4. Sorry. 12 plus 4. 16 over 6. Now we should find the LCM for. Find the LCM 4, 3 and 6. LCM is 2 into 3, 6. What do we do?
6.
Yeah. we
Convert the
multiply by 2.
denominators to 6.
Now it is 16 over 6. 16 over 6. So what are we going to say about these two fractions? They are equal.
They both
Yeah, 2
equivalent.
upon 3 is equal to 2 and 4 upon 6. Very simple. Take it down, please.
Finish, sir.
Sir, I done my work.
We don't say I done my work. I have done my work. Okay? We learn
Sir,
with the
I have done my work.
Very good. I have done my work. Okay. You guys have done the work. Very nice. Very good. Now let's look at another two sets of fractions. After this, we'll be finishing off comparison of fractions. 5 and 2 upon 3. 5 and 5 upon 7. This is quite a bit difficult one, I would rather say. 5 times 3 plus 2 over 3. 15 and 2, 17 over 3. Here, 5 times 7, 35 plus 5 over 7. 35 plus 5 is 40 over 7. Look at that. By the look of it, it does seem a little bit difficult. But let's see. For 3 and 7, what is the LCM, Pute? What is the LCM now? 3 into 7, 21. LCM is 3 into 7, 21. So I multiply top and bottom by 7. What is 17 times 7, children? 49, 9, 4, 7 times 1, 7. And 4, 11. 119 over 21. Multiply this by 3. 40 times 3, what is it? 120 over 21.
120.
Yeah, it's a very close call, no? 119 or 21, 120 over 21. So this is the larger fraction. Did you understand this, children? Yes? Yeah.
Yes,
Now this
sir.
is this is what we call a close call. Yeah. Because now you see that 119, 120. Isn't So you should understand that there are instances where you have to go through the process of finding the LCM and then get the value. Right. Take this down. We'll be moving on to the other lesson, which is what is it? Fractions part 2. We'll be moving on to fractions part 2. Right. Take this down.